Welcome to Brain Vision.
So let's go ahead and use the chain rule to find these partial derivatives. So this tree diagram is helpful. So if you wanted to go from W to R, you can go this way, that way, or that way. Okay, so we have some partial derivatives to compute. Derivative of W with respect to X. So using this equation over here, that'll be Y plus Z. Derivative of X with respect to R, that's just cosine. Derivative of W with respect to Y. And we have a few more to go here. We need dW over dz, and that'll be a Y plus X. And then dz over dr, that'll be theta. Okay, so go ahead and plug each of these in carefully. We don't want to make any mistakes here. We have sine theta, derivative of W with respect to Z, that was Y plus X. Derivative of Z with respect to R, that was theta. Now we can go ahead and use these given values here to evaluate all these expressions. So go ahead and plug in R equals 2. And theta equals pi over 2. Plug these in for x, y, and z because we see these terms in the formulas below. So x will be 2 cosine pi over 2, which is 0. Y is 2 sine pi over 2, which is 2. And then z is 2 pi over 2, which is pi. So we have y plus z, so that'll be 2 plus pi. Cosine of pi over 2, that's 0. And then we have x plus z, so that's 0 plus pi times 1. And then x plus y, 0 plus 2, pi over 2. So we have 0 there, pi over here, and then another pi over here. And that's our first answer for derivative of W with respect to R. And then now we'll go on to the next page to answer the remaining derivative with respect to theta. So going back to what we had over here for the chain rule. So how do you go from W to theta? There's many ways. You go x and then theta, y then theta, or z then theta. And we already computed these a moment ago, so we could just plug those in. And then derivative of x with respect to theta. So recall that x was r cosine theta. So we see derivative of x with respect to theta, that'll be negative r sine. Derivative of w with respect to y, x plus z, we already computed that on the previous page. Derivative of y with respect to theta, and this derivative was also computed, x plus y, and then dz over d theta, that's just r. And so remember our values. And that these implied, if you plug these in for x, y, and z, so let's go ahead and plug these into our expression. We have y plus z, and then negative 2 times 1, x plus z times 2 times cosine pi over 2, so that'll be 0, and then x plus y times r, which is 2. So that's a 0 there, and we'll have negative 4 minus 2 pi plus 4, giving us a final answer of minus 2 pi.